Welcome back to our series on introductory statistics. I'm Mark Ledbetter. This is lecture video 42. We are in section 9.2, part 7. So in the first section of this chapter, we talked about how to test hypothesis for the mean mu when we actually knew the population standard deviation, which is sigma. That is not a very realistic situation, but it does happen every now and then. In section 9.2, we've been talking about how to perform hypothesis tests for the population mean mu when we do not know sigma, and this is a much more common occurrence in real life. So let's continue with our pre-recorded video. So how do we find this t alpha over 2 n minus 1? Okay, well, n minus 1 is, we look at our n, which is 16. So this is going to be 16 minus 1 equals, this is our degrees of freedom, equals 15. Okay, that tells us what row to go to. Now, alpha over 2, it says use a significance level of 1%. So, let me see. Where was that? 1%. Let me change to red. And it says significance level. So alpha equals 0.01. Okay. Go back to blue. Come down here. I've got 0.01 divided by 2 equals 0.005. Okay. So I need to find the t-value for under 0.005 and 15 degrees of freedom. And with this chart, it's nice because I can look at, I can find this a lot easier because of this third row down here. Oops. Okay. So I need 15. Okay. Now, if I want to look at this one-tailed area, this is going to be alpha over 2. If I want to look at the two-tailed area, this is alpha. Okay. My test statistic has alpha over 2 in it. So, you know what? I'm going to, I can either use, using this one's a little more difficult because it's good for the confidence interval. It's not so good for hypothesis testing. All right. So I need to find 0.005. Here it is, 0.005. Okay? Because that's what I found here, 0.005. And I need 15 degrees of freedom. And I've got that highlighted here. So I need to come down this row. And I need this number right here. So this is my n minus 1, the degrees of freedom. It's n minus 1, that was 15. And then this here was alpha over 2. So alpha over, sorry about that, sometimes my iPad does that. So the alpha over 2, the one-tail area, all of the test statistics that I give you on the formula sheet have one-tail area in them. Okay. So we're going to use the top line, and we found 0.005, and we found degrees of freedom is n minus 1, which is 15, 2.947. Let's go back, and this is negative 2.947. Don't forget this says a negative right here. So what we're doing is we're going to find this area, but we're also, because this is a not equals to a two-tailed test, we're going to find this area, and we're going to add them together. Okay? That's what we would do if we wanted to find the p-value, right? So now, and that's probably confusing, so let me redraw this. What we're going to do is we're going to look at, try to draw this a little bigger. This is our critical value. So negative 2.947. And we're saying that if T observed is that small or smaller, if it's smaller than negative 2.947, then we reject. It turns out that this statement is not true. Negative 1.962 would be, say, over here. Let me change colors and say it would be like right here would be negative 1.962. So it's not smaller. Smaller is down here on this side. So our negative 1.962 is not in the rejection region. This statement is not true. So do not reject H naught. So there doesn't, decision first. Fail to reject H naught. There does not exist sufficient evidence to support the claim that the mean slab difference in Vail, Colorado is different than the mean thickness in Canada of 67, and that's centimeters, not inches. So let me just redo that. There we go. At a 99% confidence level. It's not always that, but in this, the examples that I've done, they've said that the significance level, a 1% significance level, equals alpha. So that's a 0.01, and C is equal to 1 minus alpha, which is 0.99, which is 99%. So the 99% confidence level using a simple random sample of 16, size 16. There were 16 for this. Okay, so that's how we do a problem. Now the difference is if we have mu equals to, so in this case we said we have, where's our 67 centimeters versus not equal to, and we had less than, so 67 centimeters. But what if we just wanted to test that the thickness was less than 67 centimeters? Okay, so we can do this because our sample mean, x bar, is less than what we're proposing as mu. We certainly wouldn't test that it was larger than, because x bar is not larger than 67, it's smaller than. So it doesn't matter what x bar is, we can always test the different than or not equal to. But it is important when we're talking about the one-sided or one-tailed test. If x bar is less than mu, we can test the less than. If it's greater than mu, we can test the greater than. Okay? But we would never test both of those. If we just wanted to test different than, it doesn't matter if x bar is bigger or smaller than mu. We can do that. We can always do the two-tailed test. But let's say that we're not interested in it being different, but that it's less than, that the average slab avalanche has a lesser thickness in Vail, Colorado, which is south of Canada, so that makes sense. It's less than 67 centimeters. All right. So test statistic, T observed, is going to be exactly the same. What was it? A negative 1.962. But now our rejection region, we need to go and we want to pay attention to the less than sign. So that's not the right spot. So we want to come over here. Oh, I don't want to do that. I just did. Must have clicked on something. Oh, yep, I did. I changed documents when I didn't mean to. Okay, so let's clean this up so that we can see what we're doing this time. All right. So now I'm looking at, for H1, I'm looking at less than. I've got this less than sign. This is what I want, and I don't know sigma, so I need this as my rejection criteria. Now notice that when we did the two-sided, we had alpha over 2. But now that we're doing the one-sided, we only have alpha. So again, every one of my formulas that I've given you has the one-tailed probability. So the probability for one tail, okay? So we need this statement, T observed is less than negative T sub alpha n minus 1 degrees of freedom. T observed less than negative T sub alpha with n minus 1 degrees of freedom. Okay, so remember that alpha was 0.01 and n minus 1 was 15. So now we're going to go and find this T, we'll find the positive T sub alpha of n minus 1, which is T sub 0.01, 15. All right, let's go to our table. Let's clean up what we had so that we don't get confused by scribblings from last time. All right. So I want alpha, and that is still, in this case, my one-tailed area, because again, I told you that all my formulas have one-tailed, and we wanted 0.01. So there's 0.01. And we want 15 degrees of freedom, which is down here. And so now our number is 2.602. And we come back. It's going to be negative 2.602, I think. Is that what I circled? Yes, 2.602. Less than, and so negative 1.962. Now, this is still not true. Okay. Here, I had to be less than negative 2.947. Here, it's negative 2.602. So it's not as small of a number, but it's still smaller than our T observed. So in this case, we still fail to reject the null. And the conclusion would be the same, except we wouldn't have different than here, we'd have less than. Okay? So everything else would be the same. All right. Well, I hope this has been helpful. You should be able to do all the problems in Chapter 9 now. Well, that's the end of this video. Please remember to scan your lecture notes before midnight of the date listed on the course calendar. If you have questions, please come to virtual office hours. I am very happy to help you, as always. If you can't do that, then you're welcome to email me. But when you email me, I need 2 things from you. The first is a picture of the problem so that I can help you through email. I may not have the problem available to me. If you don't send me the problem, then you're going to have to wait until I get back to my computer and get that problem pulled up. So please send me a picture of the problem. The second thing you need to send me is a picture of your work so far. This helps me understand how you're approaching the problem and may help me, or will help me, help you faster and better. So I hope you will stay safe and take care of yourself. Until next time, we'll see you then.